All right, guys, back to the examples. For some reason, the video quit working, so here we go. What I was saying is that it's not written in standard form, which means it's not written in descending order. So I'm going to start by rewriting this problem. I'm going to put the 25t squared first, the negative 70t next, and the positive 49 at the end. And then I'm going to go through the questions now that I have it written correctly. So that's something you want to look at. Don't do like I did where you just jump right into it and you don't pay any attention. Look at it, make sure that it is written in standard form, and then it's okay to go forth with your questions. So let's look at question number 1. What could we square to get 25t squared? We could square a 5t. What could we square to get 49? 7. Can we take the 5t, the 7, multiply and double to get 70t? Yes, we can. So the answer to question 1 goes in the front. The answer to question 2 goes in the back. The sign in the middle tells us what we're going to use in the middle. And don't forget your squared. Now looking at number 9, it can kind of look a little bit overwhelming because there are a lot of variables. Now in the last one I said about writing it in order, and this one just kind of looks weird. Like, how do you even determine what it's in order of? Well, if you look, let's say, at the x's and the y's, notice they're both squared here, and then they're down to the first power here, and then there's none of them back here. So to me, that is in descending order. Started off with a degree of 2, then a degree of 1, and then of 0. So we're just going to pick up from where it is right now. So let me real quick get these. I don't know why I put parentheses around that, y'all. I'm losing my mind from being home too much. Of course, it could be because I have a headache. That's a possibility. All right, y'all ready for question 1? What could we square to get x squared, y squared? Well, how do you get an x squared? You got to square x. How do you get a y squared? You got to square a y. So question 1 is good. What could we square to get 9a squared, b squared? Well, you need a 3 to get the 9. You need an a to get a squared, and you need a b to get b squared. So we're good. Can we take the answers we got for question 1 and question 2, multiply those together, and then double it to get that weird looking guy in the middle? Sure we can. So according to our pattern, we're going to use what we have in question 1 in the front, what we got from question 2 in the back. The sign in the middle tells us what sign we will use in the middle, and then we will have squared. That would be a problem where I would definitely want to use the perfect square trinomial pattern instead of trying to do a sum and product chart for that. All right, so remember I said before, we're always looking for a GCF. That's exactly what's going to happen here. We're going to continue to look for GCFs. So let's look at number 10. They don't all have a variable. However, they are all divisible by 3. So first thing I'm going to do is take a 3 out. Remember, that means you're dividing it out. So 3j squared divided by 3 leaves me with 1j squared, minus 30j divided by 3 is a 10j, plus 75 divided by 3 is 25. So let's see if I can use the pattern that we've been talking about today. So can the first one be something squared? Sure. Question number 2, is the last term something squared? Absolutely. Question number 3, is the guy in the middle twice the answers that we got from question 1 and question 2? Yes, indeed. So according to the pattern, the answer from question 1 goes in the front, the answer from question 2 goes in the back. The sign in the middle tells us what our sign in the middle is. Don't forget the squared. And then here's a really important part. Remember, you took out a GCF. Don't forget it either. It is a part of your answer. All right, number 11. Looks to me like we're going to have a GCF of 2 because all of those numbers are even. So 2a squared divided by 2 is 1a squared. 28a divided by 2 is 14a. And 98 divided by 2 is 49. All right, so let's take a look at what we have. Going through the questions. Can I square something to get the first term? Sure. Question number 2. Can I square something to get the last term? You got it. Question number 3. Oh, and I'm writing the wrong thing. I need a break, I think. Is the one in the middle twice multiplying the answers from question 1 and question 2? Absolutely. So in the parentheses, we're going to have a plus 7. Outside of the parentheses, we're going to have an exponent of 2, and we're going to have the GCF of 2 right there, and we're done. Now look at number 12. Number 12, what do you notice? First thing I notice is that the first term is negative and the last term is negative, and you might remember that I said that those things need to be positive. How can I make them become positive? Guess what? You can take out a negative number, because when you divide a negative by negative, it turns it into a positive. I have a sneaky suspicion that 3 will divide into all of those, so I'm going to take out a negative 3. All right, so negative 3 divided by negative 3 is positive 1, so I have a 1g squared. Positive 36 divided by negative 3 is negative 12, so I have minus 12g in the middle. And then negative 108 divided by negative 3 is positive 36. That now allows us to have the first term and the last term being positive. So let's go through the questions. Can we square something to get g squared? Yes. Question number 2, can we square something to get 36? Again, yes. Question number 3, can we take what's in the middle, and would that be equal to 2 times the answer that we got from question 1 and question 2? And we get yet another yes. So inside of the parentheses, we're going to have g minus 6. Again, I have a minus because my middle sign is minus. That's after we took out that negative 3. Speaking of that negative 3, don't forget it. It's your GCF, and also don't forget the squared. That's a part of the pattern. Now, of course, you would know that I would throw fraction in because fractions are fun. So here we go. First question, can we square something to get the first term? Yes, we can. Second question, can we square something to get the last term? So remember I gave y'all a hint and I said if fractions freak you out, look at each number separately. What could I square to get a 1? That's easy, 1. What can I square to get a 9? Also easy, that's a 3. So 1/3 squared is 1/9. And then the last question, can we take the answers from question 1 and question 2, multiply it and double it to get what's in the middle? And that's yet another yes. So how will this look? We will have d plus 1/3 squared, and that will be our final answer. All right, we are getting close to being done. So number 14 says find all values of c so that each trinomial is a perfect square. In other words, we want to be able to answer yes to the 3 questions. So let me just start by writing down those 3 questions. So the first term needs to be a perfect square. The last term needs to be a perfect square. And the one in the middle needs to be twice the product of what we get in question 1 and question 2. All right, so one thing I know is I can't start with question number 1 because I don't know what c is. So I'm going to move to question 2. Can I square something to get 49? Yes, a 7. That also tells me that that 7 would go right here. Does that make sense? Because in question 3, you're always trying to multiply what you got from question 1 and question 2 together and then double it. So that would go right here. We need to figure out what is going to go right there. Well, let's see what we have so far. We have 2 times 7, which is what? It's 14. Well, we need to have that equaling a 28x. So here's what we have. We have 28x equals 14 times something. And I need to solve for the something. How do I get this question mark by itself? Guess what? I'm going to divide both sides by 14 so that I get the question mark now by itself. 28x divided by 14 is 2x. So if I put a 2x here, because now I know what the question mark would be, right? This would be a 2x because the goal is that all of these have to be true. Then if I put a 2x back here, what would the value of c be? Well, take your exponent and make it go to that. What is 2 to the second power? It is 4. So c is 4. All right, number 15, same idea. So first term needs to be a perfect square. Last term needs to be perfect square. Middle term needs to be twice the answers from 1 and 2. So let's start with question 1. Can we square something to get 16m squared? Yes, 4m. Question 2, can we square something to get 25p squared? Yes, 5p. So now I could take the 4m and the 5p and plug them in down here for question 1 and question 2. And let's multiply that side together. 2 times 4 is 8. 8 times 5 is 40. And then you have the m and the p. So what do you think that means for c? C could be 40. Now what else could C be? See, up here we only had one option because 2 squared, there's only one answer to that, that's 4. But what do you know about the middle term? The middle term is also allowed to be a negative number. So this could be 40, or it could end up being a negative 40 if this middle term were going to be minus. So either one of those would work for number 15. Okay, so I think well, let's look at 16. We'll go ahead and go on with it. It's the last example. It says a square photograph is placed in a frame that's 2 inches wide on all sides. Okay, so here's my square. What do you guys remember about a square? Hopefully you remember that all of the sides are the same measurement. It's placed in a frame that's 2 inches wide. So here's what that means. That means up and down here is 2 inches, up and down here is 2 inches, and also side to side is 2 inches. Does that make sense? Okay, do they tell us the measurement of the original square that we drew? They do not. But remember we said a square means that all your sides are equal. So if this side is x, then this side is also x. Actually, all 4 sides are x. Okay, it says if the measure of the area of the frame is 184 square inches, what are the dimensions of the photograph? Okay, so let's think about this. The frame is this part that I have just drawn those diagonal lines through. So let's talk about, we've done a lot of area problems lately in this chapter and in the last chapter. How would I find that shaded region? Let's just talk ideas here. Shaded region. Well, it's the same idea we've been doing for a long time. We're gonna take that big shape and then we're gonna subtract the small one that's on the inside that doesn't have the diagonal lines that I drew running through it, and that would give you your shaded area. Does that make sense? So we're gonna start off with this big square and then we're gonna subtract out the small square, and that's gonna give us the shaded area. Hopefully that makes sense. So the shaded area represents the frame, which we know is 184. Now let's talk about the big shape. If I wanted to know what all of that is, let's look at what we have. I know this is 2. I know this is x. I know this is 2. So if I want to go all the way across, what do I need to do with the 2, the x, and the 2? I need to add them together. 2 plus x plus 2. Now I have some like terms there, don't I? 2 plus 2. So I'm going to rewrite this as x plus 4. X plus 4. Now let's look at this. What's going to happen going that way? The exact same thing. 2 plus x plus 2. Also x plus 4. Makes sense because what shape did we say this was? It's a square. What do we know about squares? The length and the width are the same. How do you find the area of a square? Length times width. And guess what? They are the same. All right, minus small square, length times width, x times x. All right, so 184 equals, what do we have to do right here? Do you guys remember? This comes from chapter 6. We have to FOIL it out. So first we would do x times x, which is x squared. Then we would do outer, x times 4 is 4x. Then we would do inner, 4 times x is 4x. Then we would do last, 4 times 4 is 16. So this right here is a great reminder of foiling. First, outer, inner, last. And then back here we have minus what? X times x is x squared. Now over here we have 184. On the other side, let's look at like terms. We have an x squared, and then we have minus x squared. What's going to happen to my x squareds? They have canceled each other out, right? They're opposites. We got a positive one, we got a negative one, they're gone. Then we have 4x plus 4x, which is 8x, and then we still have the 16. What do we need to do with that 16? We need to subtract it on over, which is going to give us 168 equals 8x. How do we get x by itself? We're going to divide both sides by 8, and 8 is going to go into 168 evenly 21 times. So let's go back and reread the question so we can answer it. It says, what are the dimensions of the photograph? Remember, the photograph is that white square. That was the picture. The part around it is the frame, but we just want to know the photograph. So x by x. So 21 inches by 21 inches is the dimension of the photograph. All right, a lot of good stuff there. That's the last new stuff prior to Friday's test. So as we are meeting, we're going to be meeting on Zoom for the rest of the week, Wednesday, Thursday, Friday. Wednesday and Thursday, we're going to be doing a lot of review. So you need to come prepared with having those assignments that I've asked you to be done by that time, to be done. Look in RenWeb. You can also check out the email that I sent out on Sunday because it also has a picture of the assignments that are due. So I will be seeing you guys tomorrow.